Hello, everyone. Thank you so much for joining us in this session in jconf. My name is Ray. I'm a developer advocate for Google Cloud, and I love to bring some of the best technology that Google has to offer to developers all over the world, especially to Java developers. I've been a Java developer for most of my professional career, and I love to make Google Cloud the best places to run your Java applications. If you have any feedback or any questions, feel free to reach out on Twitter, which is @Satanism. And you can also find me on my website, which is satanism.me. And today, I'm very happy to have a very special guest to do this talk with me.
Thank you, Ray. It's a pleasure to be here with you. Well, my name is Rodrigio Graciano. I'm a principal software engineer at the Bank of New York Mellon. I'm also one of the leaders of the New York Java SIG. And you can find me on Twitter at Rodrigo Graciano, and my blog is graciano.dev.
Yeah, and it's so awesome to have him here because I live in New York area, and this is one of the best community to be part of. And thank you for organizing it, and also thanks for having me speaking at Java SIG from time to time as well.
No, thank you, Ray. It's always a pleasure to have people like you, and people like you to make the community great. Thank you.
Yeah, likewise. So let's get into the session. Today we're going to talk a little bit about debugging and troubleshooting of Kubernetes and for your microservices. And to do this, we created a very simple, straightforward application to show all the different tricks you can use. Now, as you can see, neither of us are front-end developers. And so this is just straight up HTML. There's no JavaScript. It's just bootstrap with the default theme. However, it does have two of the best demo applications put together. What are those? It's the guestbook application and also a Hello World application. Very popular, of course.
Absolutely. It looks nice, the layout, Ray. I love how the columns are very aligned. Perfect. Good job.
Yeah. That's just regular HTML with tables, not even divs, because I don't know how to use divs. Yeah. So the high-level architecture looks like something like this. It is broken down into different microservices. So we have the UI, the front end, and also two backends behind the scenes. We have the greeting service that will, call the hello service, and then it's going to say hello back to you. And then you also have the guestbook service that can store data into the database. And the Java application also have a Redis instance where you can do session replication as well. It's a very typical architecture for this type of application.
Hey. Microservices is the best.
Yeah. Of course, one can say, you can do this in a monolith. Yes, of course. But if you so choose to use microservices, we're going to be very, very popular, especially after this talk, right? Correct. So we got to make sure we can scale. Okay. Yeah. So let's go ahead and take a quick look at this application. Here, the entire microservices architecture is deployed into Kubernetes. And I have here a little dashboard that shows me what's all being deployed. And because it is using Kubernetes, what that also means is that we have codified all of these configuration into different YAML files. So for example, here, for the UI deployment, we can go in here and we can see what we codified, right? And every deployment, we can specify how many instances we want. And what's also very important is the labels, right? So every deployment, every instance of applications you run, you can have labels. And these labels are going to be super important later because labels can be used to query your instances to figure out what is running based on these labels as well. So that is what we have deployed already. And we can just go ahead and take a look here, right? So here's the public IP address for our demo. And I can go in there. And you can see the browser kind of loaded up already. And let's go take a quick look. Huh. Interesting.
Uh-oh.
Well, I had another browser open previous. Okay, that's not working either.
Did you clear your cache, Ray?
Yeah. What is that key combination? Control Shift Command R or something?
Yeah, I think so. Something like that.
Did you have a recording for this demo?
I don't, Ray. Do you have one?
No, because I guess because we're recording this right now, aren't we?
Oh, you're right, Ray. You're right. We're recording. Maybe we should just start from the beginning.
No, Rodrigo, no, because this is the 25th time that we've been doing this. I don't want to do this again. I guess we have to just go ahead with this talk and figure out the issues as is.
All right. And to troubleshoot this, the first thing I would do is look at the logs. Obviously, the her page is not very friendly, doesn't tell us much. So in the past, before Kubernetes and before I was working in a bank, when I was running applications in bare metal boxes, it was painful to to look at the message, right? Find the message. We had like 4 GB containers, 4 web containers. It was just a huge waste of time. You need to SSH to into each of the boxes. You need to look for the logs. Frequently, there were multiple files, not a single one, so it was hard. So how can we do this Kubernetes way?
Yeah. So in Kubernetes, luckily, we do have a very easy to use command line to look at the logs from the containers. So first of all, let me show you all of the instances that's actually running. So here are all the application instances running. And for any of these instances, as long as they're outputting logs into std out, we can actually go ahead and tell it. We can actually see the logs. So one of the first thing about using Kubernetes is that make sure that all of your logs are outputted to std out, and it will then be picked up through Kubernetes, and then we can see it. So for example, we can use the command line here called kubectl with -logs-f, and this will tell the logs. And then you can give it the name of the application instance, or in this case, the pod name, to see the logs. Now, quick question, Rodrigo. We do have 2 Hello World UI instances.
Right.
What are the odds for me to find this one particular error message in one of these instances?
50-50, right?
Yeah, 1 in 2. Yeah, that's very good. However, in Kubernetes, we don't always have just 2 instances running. Sometimes we may have more. Like let's say we have 5 instances running right now. So we can just scale up to 5 instances, and now we can see that we have 5 instances running. Some of them are starting. Now, what are the odds for me to find this error message now with 5 instances running?
I think that's a tricky message, but I'll stay 50-50.
What? How? We have 5 instances.
How? You just have 2 options here, Ray. Or you find it or you don't.
You're right. The outcome, there are only 2 possible outcomes. You're absolutely right. So I'm going to, take a bet here and put my odd on this one, which was already running. So I'm still having a 50-50 chance of finding this. So I can go ahead and use kubectl and be able to see just 1 log, and that's what it looks like. So now, if there are errors, we can be able to see it, and you can scroll up if you need to. But this log is outputted in a JSON format, so it's not very readable, but it is parsable later. But right now, I may need to run through some kind of filter, so I can use something like JQ to parse the JSON log, and then we can do something like -r from JSON, so that it can parse the logs properly. And then we can unroll this into just the message itself. And now I can see some nice error messages. Okay, that's only because I'm using JSON format for my logs. And here we go. We can see the arrow and the stack trace. And we can, of course, investigate a little bit more into it. However, what you also mentioned earlier was that in the past, you have to SSH into individual boxes, right? Find the right application instance. I think we solved half of that problem, right? Just allowing you to see the logs directly.
That's right.
However, if you want to see all of the logs, then you can use something like there's another tool called Stern and another cool tool called kubectl. Both of them allows you to be able to specify an entire application name, like Hello World UI. This is the deployment. And what this will do is to go find all the running instances of this and then string the logs to you. Okay? And now, any instance that receives this error or any instance that's outputting the log message, you'll get to see it here in one place. That's pretty cool.
Yeah, that's very interesting, Ray. But that doesn't really work in production, does it?
What do you mean? Like right now, like this, yeah.
Yeah, but I mean, you're just seeing the tail of the log, right? So once our application becomes very popular, the logs will fly by really quickly. So it's going to be like the matrix and all the letters passing by, right? So
yeah.
What we need is centralized logging. So where I used to work, we were using Logstash, where the logs are automatically collected, and I can search from a single console. Would be nice if Kubernetes had something similar.
Yeah. Actually, you can actually use ELK stack, the whole stack, Elasticsearch, Logstash, Kibana, all together in a Kubernetes cluster. That would be one of the popular open source ways to do this. And the way that it works is that anything that you output to std out, they'll just pick those up and then put into the centralized logger as well. Now, because we're running our application on Google's Kubernetes engine, we also have centralized logging built in. And what that means is that right now, we can just go to our logging console. So I'm going to navigate to my log viewer. And from here, I should be able to find my log messages directly from here also. In fact, like for example here, if I want to find my resources, maybe I can say I need to see a Kubernetes container right there. And then I can drill down into which cluster do I want to see. And then, I'm using the default namespace. This is what my application is, and so on and so forth. And this will help us to narrow this thing down into the application that I want to show. And furthermore, I can also just see and search for exception, for example, and run the query. And here we go. So now we can see all the arrows that has exception here. And now this is also nicely formatted, and we can get a lot more information from here.
But sometimes when you do get these errors, exceptions, we may need to ask more questions. Right? For example, is it isolated to a single instance, or is it happening to all of them? For example, if it's 2 a.m. in the morning and the issue is happening only to one instance, right? I'll probably just want to kill this instance and then go back to sleep.
What? But you can't just kill the instance. But what if this issue happens again tomorrow?
Oh, you restart it again.
Okay. But then what if the same issue occurs again in a week?
So that's fine. We keep restarting. I'm sure many developers, they restart their app server every Sunday anyways. So let's just cron tab it.
So you put this into a schedule and restart the application every week. Incidentally, Kubernetes does have the cron tab feature. However, you should not use it to restart your application this way. Because if you restart your application, then you might not be able to troubleshoot it later, right? You cannot find the root cause. But before we even get to that point, let's go ahead and see if we can get more data from the logs itself. And with a centralized logger, sometimes they do provide you additional capabilities to do a search or query, right? So for example, here on Google Cloud, what I can also do is to stream this log into something called BigQuery. And so with BigQuery, it will allow me to use SQL statements to actually query the logs. Okay, so to do this, I can create a sink, and here we can send and stream the log to another destination. We can even stream it to another provider, for example. But if you want to do near real-time analysis on your logs, you can stream the logs to a pops-up topic, or you can stream it to BigQuery. So now in BigQuery, we can go and search our logs. So let's go ahead and find this. So in my console, I'm going to go to BigQuery. It's here. And I already have a table here with all my logs, right? And here's my std_out logs. And I can preview the logs. But that would just show you every single line of logs that's actually there. But what I really want is to be able to query it. So I do have a query that's saved. Let me just show you the query real quick. And here is a SQL statement, for example, for me to find this information. So I'm going to zoom in a little bit so people can see it. So here we are doing a select from our table, but then I can limit it to certain timestamp. And we can narrow this down to a specific container. And then we can do a like query on the exception. And finally, we can do a group by the name of the instance and then do a count, right? So whichever instance that has the most issues will surface to the top. Oh, there you go. So in this case, I have one single instance that has the issue.
All right. That's good. That's good information, Ray. Oh, if that was really happening where I work, I would keep this instance running and redirect the traffic to the ones that are okay. That would give us time to investigate the issue without affecting the users. I would first try to reproduce this issue on that particular instance. I'll make sure that they are running the same version of the application and things like this. What's the parallel in the Kubernetes?
Yeah. So parallel in Kubernetes, you can do very similar thing. What you described is really useful, right? Because then you can do some root cause analysis if you suspect one instance is going wrong. In Kubernetes, what we can do, because we configured these Kubernetes services, these are load balancers in Kubernetes term, and these load balancers will find the backend that's running by using the labels. Remember at the very beginning, I talked about labels.
Yeah.
So it's going to go to my backend, these pods, and find out whether these labels matches. Okay. So we have the app label, which is the name of the app, but also in my case, I added whether it's serving or not. Okay. So what we can do then is to modify the label if we want to. So for example, if I say get pods with -l app and serving, what this will show me is all the instances, but also the value of their label. So you can clearly see the serving label here, they're all true. If we suspected one of these instances has the issue, what we can do is to change the value of the label. So I'm going to say label and set the serving to false. There we go, that's much better. I also need to make sure I'm labeling the pod. There we go. And then now if I go back and look at the app serving label, now it's false. But check this out also. Because we told Kubernetes that we wanted to have 5 instances, and we took 1 out of service, and now Kubernetes is automatically starting another instance for me.
Yeah, that's really nice, Ray. I love this functionality because to do the same in bare metal is impossible, right? It's not easy to do. So that's very useful.
Yeah, so Kubernetes automates a lot of these steps for you. I would imagine in bare metal, you would have to go and figure out how to create a new instance and then start it again. But now, once we have this application isolated, it's already taken out of the load balancer too, like what you have done in the past. But also, we can isolate this instance and run more commands with it. So for example, if you really want to see if this instance is the root cause, then what we can do is to establish a port forward into this instance, and then I can bind it to my local port. And what this will do is to establish a secure tunnel that will route the traffic from my laptop or my desktop into the remote cluster and into this particular instance. So I can go ahead and say curl localhost 8080, and now this is going to that specific instance. And if there's an issue, we will know. And it looks like it's working actually. The other thing you can do is that since this instance is now isolated, you can also exec into it. So what that means is that you can run a command inside of this instance. So for example, I can say bin bash, and this will execute bash. So now I'm actually in the container in this particular instance that we think is having issues, and then we can troubleshoot it. For example, we can give it a kill 7 to force a thread dump, and we can do other things.
Yeah, this is great, but a slight problem. I guess you forgot I work in a bank. I can't just SSH into the prod machine.
That's right, yes. And in fact, that's probably the same thing for many other companies too. And don't worry, because Kubernetes does give you a lot of the RBAC control, so you can specify who can actually be doing this. Some people with break glass privileges should be able to do this, right? So that's pretty cool.
All right, so we're back to square one. It can be very complicated to troubleshoot a microservices architecture. So we need to have a bigger picture. There must be a way to visualize all the communication between the services. I want to know if they are active, they're broken. Well, tell me there's a way to get this information, Ray.
Yeah, so one of the things that we can do is to kind of visualize the network connections between them, right? So for example, because one service is calling to another, so actually I have a diagram here, and I just forgot about it, right? In this diagram, I already have, my applications. You can see it, I got these lines that this application instance is talking to the guestbook service, right? So we have some kind of topology here.
Yeah, Ray, I don't know. Is that real? Because to me it looks like a visual diagram.
Well, yeah, but it is, right? Because we had 2 instances, but then now we have 5 or 6, however many that I created.
I don't know. I look at those dashes. I don't know, Ray. I feel something going on here.
You caught me, Rodrigo. So these lines are actually not reflecting the reality. Yeah. Right. So for example, the trick here is that in this custom-made visualization tool, in my YAML file, actually this one with the deployment, we have the visualization annotation here. So I actually hard-coded and sheeted here. So all the lines are drawn based on what I hard-coded here. Yeah. So rather than doing this, and this is almost like documentation, right? And I don't know, like if you ever had the experience where, somebody tells you something's wrong, you troubleshoot it, and then you follow some documentation, make some assumption, and then another person said, well, that documentation is kind of out of date. So you don't want to trust somebody's documentation. What you want is something that's more real time. So there are some tools you can do that with. So first of all, to see the network topology, there's a really nice tool called Weave. So I think I should have this up and running, where you can say localhost 4040 in this case, and now I can go ahead and see the topology of my network. This is super, super cool. In fact, I can even zoom in here, and let's look at only the default namespace. Oh, that's a lot. Maybe just this one, right? And maybe just the controllers. And if I can zoom in a little bit, there we go. So we can clearly see Hello World Service is here and Hello World UI is here. And if I were to make another request, if there are live connections, this will actually update in a second. There we go. You can see it. So now you can clearly see all the networking is actually working pretty well. That's really neat.
Absolutely. So the network topology is great for seeing network-to-network connections. But I need to know how a particular request failed. And for this, we need to see a distributed trace. Even in the old days of SOA, we used to have a request ID in the message header. And that would allow us to trace the message end-to-end across services. This was extremely useful to debug the code. Otherwise, how would you know which message failed, where it came from? And that was more than 10 years ago, and it's the predecessor of modern-day distributed tracing. So to debug this, we need to see the distributed tracing graph rather than network topology graph.
Yeah, that's a great point. And fortunately, my application does have distributed tracer already. I'm using Spring and Spring Boot, and behind the scenes, I'm using Spring Cloud Sleuth to do the distributed tracing for me. And then you can collect the traces in a central tool. In the open source world, you can use like Zipkin or Jaeger to see these distributed traces. But you can also, send the traces to Google Cloud, so you don't have to manage those instances. So I can go to trace and see the trace list. And here, every dot is a single trace. So for example, if I click on that one, and I can see the failure already. Okay. But if sometimes you have more than one trace, you may actually want to do a little filter. So you can say, I want to filter by the status code with the output status code of 500. Right? And now here are all my traces, which has the status code. The other thing that I can do is that for every trace, my log is actually associated with the trace, so I can see the logs associated with each of the requests. This is super useful, especially if I output some exception that's associated with the trace. However, here we can also see it tried to make a call to Hello World service with a certain path. And then here we can clearly see we're actually getting the 404, right? So in the log, we may be able to read this, but sometimes the log is incomplete. But at least here, we can see that we have status code 404.
Okay, so now we know what method caused it. So this explains where the 500 came from, and it was caused by a 404 error on the second service. But we still have more questions. So why was the second call a 404? It was working perfectly in staging.
Yeah. So sometimes, as we dig deeper into this, if I were to have made this trace even better and more useful, I may have to, add a tag or additional labels so that I can see the input parameters to this remote call, right? However, I don't have this, so I guess we need to find more information about what the user may have entered that could have triggered this error.
That's right. The current log is horrible, so we need more logs. And how can we add more logs in production right now? So if we're lucky, you could turn on just more logs, enabling a finer log level. But Ray, I don't think we have any other log entries here, so we actually need to modify the code. So just imagine, it's 3 a.m. in the morning, and I need to add a new log. So I need to get the right revision. I need to change the code. I need to build the application. I need to wake up my manager. I need to wake up the support team. I need to get their approvals. So, and that, you see, it's a 5-hour job. It's got to be a better way to do that.
Yeah, yeah. And by the time 5 hours is over, customers are really unhappy already, and we still haven't really solved any issues, right? There are actually better ways and easier ways to do this, again, with the right privileges, with the right purpose to do the troubleshooting. All of our applications right now that's being deployed, I added another agent, and this is the Cloud Debugger agent. And what this will allow us to do is to actually add logs to my application without affecting the runtime code, and also without having to change the source code either. This is done by pure magic, I think, of the JVM and the agent. And here I already have different applications running, and this is my Hello World application. And I can select it, of course, and now I can go and see the source code. The source code is automatically pulled down by using some metadata I have in the app, so that it's checked out the exact same revision from my Git repository as the one I deployed. Okay, so you wouldn't be troubleshooting the wrong code base. That will also be very time consuming, right?
Right.
But now, once we are here, then we can use something called the log point. This is right here on the right. And what log point allows you to do is to just add logs. So have you heard about the term called binary log debugging?
Binary log debugging.
Yeah.
You're making this up right now.
No. I think this is real because I do this every day. I think everyone does this a lot. So this is how it works. First, you have a log on the top. So that's your beginning. And then you put a log in the end. And as you can see, I'm just putting a new log right now. And now I just add a log to my application. Okay. And then if it didn't make it to the end, I just add one in the middle. So I can say name is name, like that. Okay? And now if it didn't make it to the name, then I think it's between in the first and the middle. If it made it to the end, didn't make it to the ending, then it's between these two, right? So now that's binary debugging with logs.
That's funny, Ray. It reminds me a time when I need to debug JavaScript. You go exactly like doing like this. But I think we're getting closer to the problem. But you know what would be really nice? It would be nice if we could just add a breakpoint and debug the code.
Ooh, that's dangerous. Are you sure you want to do that? Because in production environment, if you attach the debugger, once you start the session, you're going to stop the world, and all of your users will be hung until you finish the debugging session.
Oh, but that can be good. Because they can wait, I get call in, I step through the code, I fix the issues, everyone gets happy. And that's what I call job security.
That is true, but we have definitely a better way of doing this as well, and that can get you even better result. And what we can do is that with the same debugging agent, we can take a snapshot instead. So snapshot is just like a breakpoint, except it does not stop the world. So for example, I can take a snapshot here, and if I suspect that I have some issue with the way I'm calling my service here, I can take another snapshot here. And now if I go back and refresh my page, now did you see that? The snapshot was actually taken because the code executed through this path. And we can see the state of the variables, and we can very clearly see that the name is actually empty.
All right, so let's do a quick recap here. We demonstrated how common issues can be addressed using Kubernetes and lots of different tools. So we use kubectl to extract information. For example, we use kubectl logs and Stern to look at the application log. We use Google Cloud Logging, but we can also use some open source tool like ELK Stack. We talk about centralized logs and how we can easily query the log to get more specific info using BigQuery.
And then we also try to determine the issues between the microservices using distributed tracing. That's definitely very important, and you should always add the distributed tracer to your microservices application. And then you need a way to collect your traces. For that, you can use something like open source tool like Zipkin and Jaeger, or if you're on Google Cloud, or if you want to use CloudTrace, we can also collect those traces for you. And finally, when all things failed and you really need to figure out what is wrong with the application, you need something to go in there and add more logs and debug it live. You can do that too with the right privileges, and that can really help you to troubleshoot some really hard to find issues. So with that, thank you so much for being here. And if you have any questions, please reach out to us. and follow us on Twitter. And here are some resources you can check out. Thank you.
Thank you.